Hello students, today we are going to study photogrammetry. Now photogrammetry is the science of obtaining information about physical objects through the process of recording, measuring and interpreting of photographs of the area. Now if it is not possible to take the data of any particular area by just visiting on that area, we can take the photograph of that area from the air with the help of aircraft. We can completely determine all the information about that area. Now aerial photogrammetry is the branch of photogrammetry in which photographs of the area are taken with a camera mounted on an aircraft. Here an aircraft is shown like this, and in this aircraft a camera is mounted like this, and it will take the picture of that particular area. Now the main advantage of aerial photogrammetry are the speed with which an area is covered, the ease with which topography of inaccessible areas can be detailed. There is no possibility of omitting any field data, and the tremendous amount of details shown. That are the advantages of aerial photogrammetry. Now generally aerial photographs are classified into two types. First one is vertical photograph and the next one is oblique photograph. Now vertical photographs are taken when the camera axis is vertical. It means that when the camera axis is kept vertical, then the photograph taken is known as vertical photographs. That is, it coincides with the line of gravity of camera. Now when the camera axis is perfectly vertical, the photo plane is parallel to the datum plane and the resulting photograph is truly vertical photograph. Now when the camera axis is tilted slightly from vertical, the resulting photograph is known as tilted photograph. It means that if the camera axis is tilted like this, then this photograph is known as tilted photograph, not the vertical photograph. The tilt is generally less than 1 degree and rarely exceeds 3 degree. This tilt is unintentional. If the tilt is less than 1 degree or up to 3 degree, this tilt is unintentional and we can say that this photograph is vertical photograph because the tilt is unintentional. Now moving to the next photograph, that is oblique photograph. Oblique aerial photographs are taken with a camera axis considerably inclined to the vertical, which is shown here. The camera axis is intentionally kept oblique from the vertical. Now we will see why we kept the camera axis intentionally inclined to take an oblique photograph. Okay, this is a ray diagram of photograph. That is the lens of the camera, that is the negative of the camera, and we can say that if negative will lie at a distance of small f, that will be the focal length of camera, then positive will be at the same distance f on the front side of the lens. And this is the ground level which is shown here, and this is the datum surface. Now the flying height of the aircraft above the datum is represented as capital H, and above the ground level is known as H dash. This is the point or the area whose photograph is to be taken, that is AB, and this is the optical axis. Now the negative image of capital A will be small a dash, capital B will be small b dash. So its positive image will be small a and small b, which is shown here. Now we know that the scale of photograph is known as photo distance upon ground distance. Now here in triangle LAO and triangle LAP, we can say that AO upon AP will be equals to F upon H dash from the concept of similar triangle. Now we can say that AO is half of AB, so we can write it as AO is half of AB. Similarly, capital AP is half of capital AB and it will be equals to F upon H dash. Now from this two cancel out and photo distance upon ground distance is nothing but the scale. So AB upon AB is equals to S, and the formula will be equals to F upon H dash. Now if we want to write this formula as per the capital H value, then it will be equals to F upon capital H minus small h. Small h is the elevation of the ground from the datum, which is shown here. Now if the ground is flat, then this formula holds. If the ground is flat, and if the ground is undulating, then we have to modify this formula and we have to write it as F upon H minus H average. We have to determine the average value of the elevation of the ground from the datum. So it is used for the undulating terrain and it is used for the flat terrain. Now if we want to compute the flying height from this formula, then it will be equals to H dash, that is above the ground surface, it will be equals to F upon scale of photograph. That will be the formula for flying height of the aircraft, that is capital H dash is equals to F upon S. So we will write all the formulas, that is the scale formula for flat ground, it will be equals to F upon H minus H, that is for flat terrain. For undulating terrain, the formula for scale is F upon H minus H average, that is used for undulating terrain. And for the computation of flying height, that is H dash, the formula is F upon S, flying height. So we had computed the scale of photograph as well as the flying height of the aircraft. Now the next topic is the relief displacement. Relief displacement is the shift in an object's image position caused by its elevation above a particular datum. Now if we take the vertical photograph, then in the photograph only the plan of that area will come, okay? But if we keep the axis of the camera inclined with the vertical intentionally, then we will take the oblique photograph of the object, and when we take the oblique photograph of an object, then in the photograph the height of the object also comes, that is shown here, and that horizontal distance on the photograph is known as the relief displacement. So relief displacement corresponds to the height of the object on the photograph. Now for the computation of relief displacement, we have to see certain parameter which is shown here, that is the building or an object denoted by B and T. T is the top point of the object and B is the bottom point of the object. Its total height is small h. Now this is the optical axis of the camera. Capital H is the flying height above the ground level. From the optical axis, the distance up to the lowest point of the object is r dash, and up to the top point of the object is small r, and the distance between the optical axis and the object is capital R, which is shown here. Now this is the positive image which is formed in front of the camera. So this distance OP will be equals to the focal length small f. Now if we want to compute the relief displacement, then we have to use the similar triangle concept, that is in triangle POB and triangle P small o small b, then small op upon capital OP will be equals to small ob upon capital OB. So the value of small op will be small f and the value of capital OP will be capital H, and the value of small ob will be r dash and the value of capital OB will be capital R. We can write it as, from this, f will be equals to r dash upon capital R into H, and r dash can be written as capital R minus D. So it will be equals to R minus D into H is equals to Fr. That will be our first equation. Now we will use the next triangles, that is in triangle PO small t and triangle PMT. By using the concept of similar triangle, PO upon PM will be equals to OT upon MT. Now the value of PO is small f, the value of PM will be equals to H minus H, the value of OT will be equals to R, and the value of MT will be equals to capital R. From this, FR will be equals to R into H minus H. That is our second equation. Now from equation first and second, the value of Fr is same. So we can write it as R into H minus D into H will be equals to R into capital H minus R into small h. Now from this RH will cancel out. On solving this, we will get the value of relief displacement as D is equals to R into small h upon capital H. That will be the formula for relief displacement. Now here R is the radial distance of the image of the top of the object, which is shown here. That is the value of small r. Small h will be equals to the height of the object above datum, which is shown here. That is small h. And capital H is the flying height above the ground, which is shown here. That is capital H. That is all about the relief displacement. Now we can move to the next, that is photographic overlap. Now in aerial survey, vertical photographs are taken at proper interval to give the desired overlap of photograph have some common coverage. This overlapping of the photographs along the flight strip is known as longitudinal overlap or end overlap or forward overlap or simply overlap. Suppose that if we want to take the photograph of this particular area, then our first flight will be in this direction, that is this. So this is the longitudinal direction, and in this longitudinal direction the photographs are taken at a regular interval like this. The overlapping between two photographs will be kept as 60% generally. This overlap will be equals to 60% generally. So longitudinal overlap will be equals to 60%. So in general practice, to have longitudinal overlap of 60%. Why overlap is considering? Because if we do not consider the overlap of the photograph, then some of the area of the field will be unsurveyed. That's why we need the overlap of the photographs. Two adjacent flight strips are so photographed that there is a side lap or lateral overlap. Now suppose that this longitudinal photograph is taken. Now if we want to move to the next flight, then we need some side overlap also in between the photographs of the two flights, and this side overlap will be equals to generally 30%. This overlap will be generally equals to 30%. So side lap generally varies from 25 to 35% with an average value of 30%. So in question we always kept the longitudinal overlap as 60% or 0.6 and side overlap is equals to 30% or 0.3. That will be the longitudinal overlap and the side overlap. Now we need to compute the number of photographs. So there will be two methods for the computation of photographs. First one is when ground area A is given. Suppose that this is a particular field area whose photograph is to be taken and we had taken another area. Now suppose that if the area of this field, that is this field, is already given, that is capital A, then we have to use the first formula, and if length and width of a particular field area is given, then we have to use the second method for the computation of number of photographs. Now according to the first method, when ground area A is given, then we have to use the formula, that is AS square upon 1 minus PL into 1 minus PS into L into W. Here A is the area given, S is the scale of photograph, PL is the longitudinal overlap equals to 0.6, PS is the side overlap equals to 0.3. L is the length of photograph in the direction of flight, and W is the width of photograph normal to the direction of flight. By this method, we can compute the number of photographs when the ground area A is given, and always remember that you have to round off this value up to the next integer value. Now if length and width of a particular area is given, then we have to compute the number of photograph according to the second method, and according to this method the number of photograph will be equals to L1 upon 1 minus PL into small l upon s plus 1 into W1 upon 1 minus PW into W upon S plus 1. Here L1 is the length of ground to be covered, W1 is the width of the ground to be covered, PL is the longitudinal overlap equals to 0.6, PW is equals to side overlap equals to 0.3. Small l is the length of photograph in the direction of flight, W is the width of photograph normal to the direction of flight, S is the scale of photograph. Now, during the calculation of number of photographs, we have to round off these values individually. After that, we need to multiply these values and we will get the number of photographs in a round off value. Okay, we do not need to multiply these values before rounding off. Okay, we have to round off the number of photographs in the length and the number of photographs in the width. After that, we need to multiply the rounded off values and we will get the number of photographs in a particular integer value. That is the two methods for the computation of number of photograph. That is all about photogrammetry. Thank you very much, students.